combat manager and counters and triggers and timers, that sort of thing, and playing animations. And you can use the same system to attach collision geometry to animations and that sort of thing. So you can say, stick this animation onto a locator of that animation, and when this event triggers, do that. So it's really powerful to pretty much develop anything you want from and all you need is an artist and a little designer, and go. Most of it's completely covered and works on all consoles. And that's another way we don't have to do things 5 times over. One of the big things with cross-platform development is obviously your modelling between DS to 360. Is it best to start low and then upscale, or start high and then cut down? And even project to project, we still argue about what we think is best, and some guys think one way, some guys think the other. And that's really what it is, depending on it's all a case-by-case situation. So on Monster Jam, the first one we did Monster Jam, and then Monster Jam Urban Assault. The sequel wasn't on 360, it was just Wii, PS2, PSP, and DS. The first one was 360 as well, so we obviously had the higher level of detail and normal maps and step maps to deal with. So on the first one, the trucks, we did the high poly meshes first, and then baked down those textures to the low poly meshes. On the levels, we do the DS one first, and then upscale. Just do a quick example. So this one on the right, you're right. That's the 360 version from the original Monster Jam. Mapped in its normal map, specular and shaded glory. And then that same model was just, the poly count's not a lot different down to where you just rely on the normal map to do most of the work for you. But then the DS one, it's very cut down. And the texture, anyone who's done any cross-platform development should know, you can just use rendering transfer maps. And you can just say transfer the diffuse texture from this model to that model. And you can include your lighting information from your normal maps and that sort of thing. So you can get a pretty nice texture for the DS or the PS2 and the Wii from your 360 model pretty quickly. I'm not going to do it back now, but it's all in there. And the models for the DS were obviously very low. This entire truck is only so 430 poly for the entire truck, and that's the high poly version of the wheels. The wheels on all the trucks just went down to, I think, 6-sided cylinders as they went further away with no strip around the middle. It's just a different texture on the roof as well, because the decals on the truck change between titles. So, the truck shells are really quick and easy to make. So initially in the game, we just put a placeholder truck for every single truck in the game, so they're all available to pick. You can get your full level playthrough with just a placeholder truck. And once the high-end ones were done, we just bake down from the high-end truck. They're so low poly, you can make the truck in about an hour, and that includes baking down the texture and wrapping movies and everything, obviously. And the beauty of building DS levels first is they're so low poly, you can make them really quickly and get them running on every platform. You obviously can't run your 360 level on your DS, but you can run your DS level on your 360 because the poly count's so tiny. So yeah, we just, on Monster Jam Urban Assault, we had all the DS levels for the entire game built in 6 weeks. And that meant the entire game was playable on every console in 6 weeks. And then from then on, we just worked on upscaling that quality of art to all the other consoles. I've got a couple of examples of the geometry from those, and sort of the changes that we go over from DS to 360.
Do you keep the geometry from all the different levels in the one main file in different layers, or do you keep more completely separate?
Usually, I would just copy it out to a new version and then we reworked on it, because once the DS levels were sort of set, we didn't want to mess with them too much. And they did get tweaked independently a little bit sometimes. Like obviously on the DS, you can't have as many textures, so you have a lot more repeating of buildings and roads and that sort of thing. So you want to change your texture assignments and various things. But this one on the DS, it's only 800 poly for this section of road, and it's very low poly. And the collision for this obviously is just almost a flat ground that just walls. And it's pretty quick and easy. Whereas the same thing here, which is over from the Wii, is around 11,000 poly for the same area. And yeah, the DS was built in the arts to go from higher res buildings and gutters and trees and whatnot. And this is before all the entity placement's gone in as well. All of the destructible objects, we call them, going on top of this. So you place all your smashable trees and rubbish bins and post boxes and fences and that sort of thing. What you see here is just the static world. So it's obviously a lot more detail. And the same geometry in our render will run on the Wii and the PS2. So we don't need to go cutting up and down for those platforms. And with the 360, ideally you just want to use the same geometry as the Wii, but use normal maps to get the extra detail. Or sometimes just some extra little things over the top which aren't there on the Wii. Yeah, and as I said, all the Monster Jam 2 DS levels are done in 6 weeks, which was a huge benefit for getting the whole game running quickly and keeping the publisher happy. Textures, another big part of development. They can take a long time to create, especially on 360, PS3, PC, where you've got diffuse from normal to spec, any other textures you might have for various effects. And of course you want to make them as small as possible. Saves memory, saves time to upload them to your console, saves space on the disk if you want to keep under a CD or 4.5 gig for DVD or whatnot. And where possible, you want to avoid reworking them as much as you can. So we try to just do a reduce with a software called Optipix. It does a way better job than Photoshop will ever do at reducing textures from, say, your 1024 down to 64 squared, and it still keeps them pretty good. But there's also a few other tricks we do in between. And we always have a good naming convention on all of our textures to make sure that you can batch things quickly. So _D on the end of every texture name if it's an opaque, or N for normal, A for 1-bit alpha, S for specular, that sort of thing. Because you need to know what the texture is to know what DXT format it needs to go through, or what PNG reduction macro you want to use. So if the artists stick to all those naming conventions, we can just press a few buttons and batch convert the entire game's assets really quickly. Yeah, so for Monster Jam, all of our textures were created at 1024 for 360 with their spec and normal maps. And then we'd render from Maya, like just stick that texture onto a flat plane, set up some nice lights around it, and then render it out to a texture for Wii, and then and PS2 and DS obviously, and then batch reduce it with Optix. And Optix you can just say, I want it 128 with only 16 colours, or I want alpha, or I don't want alpha, I want the alpha to be really good, or just quick and dirty. And it does a fantastic job of production. If you do the same sort of thing in Photoshop, Photoshop doesn't even support 16 colour PNGs, so you're just going to be wasting your memory left, right and centre if you stick to Photoshop. When you're working to a really tight deadline and a lot of consoles, we found it's just the best way. You can't afford to have artists custom tweaking textures for every single resolution and console. Sometimes you might get a little problem when you reduce high detail textures down to low res. So there's a little bit of tweaking every now and then on specific textures, but most of the time it does the job. So yeah, a little example, 360 just have your diffuse, your spec and your normal. Set up your lights. It doesn't show up too well on the projector, but you can see the one on the right, there's a bit of light, a bit of specular, that sort of thing baked into the texture. So you just get a little bit more oomph in the texture on the lower consoles. Animation and skinning data, it takes up a lot of memory if you've got lots of characters and lots of animations. Like some of the Scooby First Frights characters had 50 different animations each. If we baked out every key put in game, you'd be using 100 meg memory all the time for every character, which is just crazy. So to get it going on every console, it's just a matter of reducing bones, reducing the number of vertex weights per bone to speed up the CPU or GPU for the spinning. And we have various tools for automatically reducing the number of keyframes that are exported into the game. And they'll basically just, if it just compares 3 keys, if the one in the middle is within a threshold of the next 2, it'll just delete it. And for each platform, we just have a different threshold we can tweak. So on Scooby-Doo for Wii and PS2, all the characters were around 44 bones, up to 3 weights per vertex. Obviously we'd like to use as few as possible, but that was